Dear mathematics aspirants, right now I have the binomial theorem chapter 8 of the plus 2 level mathematics, and here you will see the scientist name Blaise Pascal 1623 1662. Based on the computer, when you study the computerization historical events evidences, then the Blaise Pascal will be mentioned. That is very important factor, that mathematics is the most exact science and its conclusions are capable of absolute proofs. CP Steen match. So you will see here the sum one quote for understanding. For understanding the fact, here the introduction. In earlier classes, previous classes, we have learned what we have studied, how to find the squares and cubes of binomial like a plus b. What is binomial? Binomial by two nomials name and a minus b. Using them, we could evaluate the numerical values of numbers like 98 whole square, 100 minus 2 whole square, 999, 1000 minus 1, etc. However, for higher powers like 98, 5, 1016, etc., the calculations become difficult by using repeated multiplication. Repeated multiplication will provide you the difficulties. For those difficulties, we have got an outcome, i.e. binomial theorem and Blaise Pascal line. Here either provide you the information. This difficulty was overcome by theorem known as the binomial theorem. What theorem? Binomial theorem provided the solution for this complicated multiplications problem. It gives an easier way to explain a plus b whole n, where n is an integer or a rational number. In this chapter, we study binomial theorem. So we study binomial theorem for positive integral indices only. So here, based on the positive integral indices only, binomial theorem of positive integral indices. Let us have a look at the following identities done earlier. A plus b whole 0 is equal to 0. A plus b is not equal to 0, and a plus b whole 1 is equal to a plus b. Here a plus b whole square is equal to a square plus 2ab b square, and a plus b whole cube, a cube plus 3a square b plus 3ab square plus b cube, and a plus b whole 4, a plus b whole cube plus a plus b is equal to a4 4a cube b 6a square b square plus 4ab cube plus b4. In these expansion, we observe that the total number of terms in the expansion in one more than the index. For example, in the expansion of a plus b whole square, number of terms of 3, whereas the index of a plus b whole square is 2. Powers of the first quantity a go on the decreasing by 1, whereas the power of the second quantities b increase by 1 in this. Powers in the first quantity a go on decrease by 1, whereas the powers of the second quantity b increase by 1 in the successive terms. In each term, the expansion, the sum of the indices of a plus b is the same and is equal to the index of a plus b. So you have observed such instances. Now we arrange the coefficient in these expansion as follows: 8.1 coefficient, and here index and coefficients given here. In next video I will provide you this information. Till then, thank you.